Dear friends, we go through a lot of boring things about the AHUs. We talked about these heat exchangers, why they're so important, the valves that allows the cooling or heating agent to pass by so the heat exchanger will be either cool or heated, the humidifiers that needs to compensate for the lack of humidity when we're running very cold heat exchangers. Here you'll see how the two-way valve control the capacity of the heat exchanger, and also you'll see the bypass balancing valves, which allows a specific quantity of heating or cooling agent to pass at any time to balance the entire system. Because think about this is just a branch of a huge system, and if you won't have these bypass balancing valves, some area will be starved and some area will got more than they need to heat or to cool the premises. Like for the heating, on a cooling situation, the same rules apply. You have an actuator which is proportional. It goes from 0 to 100%. You also have the bypass balancing valves. Imagine you have 20 heat exchangers, you have to make sure they all receive the appropriate quantity of glycol to cool the premises. These are things that has to be considered. You'll see you'll have the condensed water, the drip tray, the condensed water pipe, and now you run this system above the dew point. Do you see? You're not removing any moisture from the air because the condensate water pipe doesn't show any water, and the drip tray it's empty. If you run this unit a little bit cooler, you see now the water will condense on the heat exchanger, and on the condensed water drain you will see water, which means you're dehumidifying the air. So also, if you look at the actuator, this is in fault condition. The actuator want to close the system because the premises might be too cold, but the shaft of the two-way valve is broken, and no matter how much you manipulate the actuator, the two-way valve is seized because might be corroded or damaged. In this situation, you'll see we run a pump, and to control the capacity of the cooling we use the actuator, because this is just probably a branch. Now usually in this situation, if you don't have the balancing valve, the balancing valve which short circuit the flow to the return, you'll interlock the actuator, the valve with the pump, so until the actuator will open 100%, the pump will not run. I found the system pretty inefficient, a little bit pointless. What do you need an actuator if you control directly from the chiller or from the boiler in heating situation the temperature by working on heating agent temperature rather than bypassing it. If you're not interlocking the actuator, bad situation can occur. If the valve will be broken, like in this case, you will starve the pump. You see, in between the actuator and the pump, you will have a lot of bubbles and negative pressure, and you can burn the pump. The pump will get red hot. But even if you interlock it and you don't have like a flow switch to stop the pump, then the pump will still be activated by the interlock. This is the better situation, as I said. If you have a broken valve or something, the glycol will go through the balancing valve. Usually we're using this system for multiple heat exchangers, like you see in this video. We have two heat exchangers on the right hand side. One is warmer, the lower one is cooler, runs below the dew point. It removes water from the air, moisture from the air. The top one just cool the air but doesn't remove any moisture. If you look at the drip tray, it's empty for the top one. The bottom one, it's got water, so The bottom heat exchanger runs below the dew point. This system, it's okay, you have one pump, you have the glycol circulating through both heat exchanger, and you have actuators which controls the capacity of each heat exchanger, allowing more or less glycol to pass by. In this case we have only 2 heat exchanger, but sometimes you can have 5 heat exchangers, and that's why we're using balancing bypass balancing valves. You have to make sure that all the heat exchangers will receive the right quantity of glycol or heating agent, so they will run at 100%, all of them. So yes, I want you to consider this. This is really important, and do not ignore the balancing procedure, because if you have an unbalanced system, some actuator will get 200% and they will waste chillers or boilers capacity because they cannot heat up than the heat. There should be a differential between flow and return on a temperature. If you will allow more glycol to pass by because the system is unbalanced, you might not have the required delta T, and then your system will be inefficient. Also, we know that for a glycol, for a cooling agent or heating agent to run through a pipe, the pump must run. Even if you will act onto the actuator and will open and close the valve, the heating or cooling agent will not move through the system if the pump is not running. And if you have a very large system, you might not even hear if the glycol run through the system. You will laugh and say, that's simple, but I found technicians which didn't look and they struggled with the valve and not checking the pumps, or maybe the valve before the actuators, the valve which allow you to isolate the system if you want to remove some parts. Now if the pump runs, you will see this is a 3-way valve. The valve is closed, you will divert the heating agent or cooling agent. In this situation, the valve just open and allow the cooling agent, in this case, to reach the heat exchanger. In this case, it starts to control its capacity, returning only a portion of the glycol. Now this is again a faulty valve. The shaft doesn't, the spring doesn't push the shaft to follow the actuator. This is a proportional control actuator, and the fault is quite complicated because it runs from 0 to 100%. Now you have to see how the air is acting when the heat exchanger is running. As you see, the air is going ingredients like it's got humidity, and in this case you'll see the absolute humidity is the blue line in the middle, it stays. The relative humidity is green, goes up, and the temperature is red, goes down. So we not remove moisture from the system. If the heat exchanger is turned off, then obviously no cooling, the air come back to its original status. If you'll heat the air, now you'll see on the right hand side the red line, which is the temperature, goes up. The relative humidity this time goes down. Absolute humidity stays, not modification. Now you run the coil on the left hand side below the dew point, and you'll see the blue line goes a little bit lower, which means you remove moisture. You can see the pipe below on the left hand side is removing moisture. So the temperature goes down, the absolute humidity goes down, but the relative humidity can be higher because the temperature is much lower. And also, if you see, you remove moisture, but then with the heater you can bring the temperature back, so the air is just the way you want it to be. You lower the relative humidity and increase the temperature, and you have a perfect air for what you need to use it. If you heat the air more, then the temperature will go high, the relative humidity will go lower, but again, you won't have any modification on absolute humidity. So the only place where you will modify the absolute humidity will be on a very cold heat exchanger where the condensation will occur. So I hope you understood. So just imagine, guys, we have these air handling units, and if you do not have reheaters or recoolers, you cannot control individually these rooms. And because of this, you have to make sure that the rooms are quite well calculated, the heat load is calculated, the size of the room, the air change rates. So now we talk about the cooling and dehumidification heat exchangers, heaters and humidifier. If you want to learn more about boilers or pressurization unit, pressure vessel, pumps, integration, radiators, hot water heaters, programmable logic control integration or control philosophy, just watch my other videos. You'll find some good stuff there that might help you to understand. This is an image of an air handling unit. You'll see you bring air to one side, the air passes by to two heat exchanger, and you continue its journey to cool the premises. If you have multiple rooms without reheaters or recoolers, it's obvious that if the rooms are not well calculated, you can have different temperature and humidity in any of these rooms, because this HVAC control the global air flow temperature and humidity. Like in this situation, you can have a good control, so you'll know the temperature and humidity value of the air when it leaves the air handling unit, but when the air reaches the rooms, you will provide the same temperature and humidity for any of these rooms. And if you provide the same air change rates, then if the heat load is not well calculated, you will hit the jackpot. You will never be capable to have the proper temperature in these rooms. Some rooms will get hotter, some rooms will be cooler, some rooms will have a higher or lower relative humidity, and as I say, there's no middle way here. There's no way and nothing you can do to be able to control unless you have either recoolers or reheaters. Thank you again watching my videos, and just want you to remember, I do these videos for free while I'm in holiday or when I'm coming from work. Not asking any money, not pretending I'm guru. I'm just sharing with my fellow colleagues some of my knowledge, and believe me or not, I'm watching YouTube a lot, and I'm learning a lot from other people's experiences, and that helped me to become every day a better and better technician. Thank you very much. So I see you next.